All right, we're back. We are on page 6 still of Calc C Notes 13, I think, doing Euler's method. And what we're going to do now, we already did Euler's method. This is a really interesting problem because if you look at the values that Euler's method gives you, which we confirmed on the calculator, I mean, these are the values. And then you look at the true values of the function. There's just this insane leap here. And we discovered, because we were given the solution, that there's a vertical asymptote between 0.3 and 0.4, and Euler's method just like plows straight through it. It doesn't care. And we have to care about that. But Euler's method doesn't know any better, right? Unless you hit the discontinuity exactly and the derivative blows up on you, you'll never even know. And that's what basically happened here. So what I want to do is I want to solve the differential equation. So I'm going to solve it. You're not a laser pointer. Whatever. I want to solve this, and then I also maybe want to confirm it, but I want to solve it. So confirming it by finding the derivative and plugging in is actually like way easier, maybe. But I'm gonna try to do this. Oh, actually, it tells you to do it both ways. Yes. Okay. So we got dy dx is y squared minus 1. So this is separable. So if you're not sure if this is separable, put this in parentheses and say times 1, and now separate it. So dy over y squared minus 1 equals 1 dx. And we're going to integrate. So on this side, the left-hand side, maybe you see where this is going. We got y plus 1, y minus 1, dx. Partial fractions, we're doing it. So I'm going to do it like way down here. Say a over y plus 1, b over y minus 1 equals 1 over y plus 1, y minus 1. So, okay. So if y equals -1, then a is -1/2. And if y equals +1, then b is going to be +1/2, I assume. Yeah. So we're really trying to integrate. You know, you just take out 1/2, and you get -1 over y plus 1. Okay, so I'm taking out 1/2, and I have -1 over y plus 1 plus 1 over y minus 1 dy equals, let's just say x plus c, because we know how to integrate that, so we should. I can multiply through by 2 and like just not deal with that, so I'm going to do that. So I still have this. My temptation, I'm like so tempted to just flip the two fractions so that it's like blah minus blah, which if you did that, that's a good move. 2 times c is just some other constant that we don't know, so that's okay. Negative natural log absolute value of y plus 1 plus natural log absolute value of y minus 1 equals 2x plus c. So on the left-hand side here, am I going to have to worry about these absolute values? What do we know about y? We know, well, you know what, that's actually, I think that's the problem, is that since the initial condition has a positive y value, we should restrict ourselves to y greater than 0, I think. So do I really think that? I don't know. I mean, I think that. I'm gonna take the lazy approach and just be like, I think I can drop these. I think that what'll happen is the ratio will fix it. I don't know. This coefficient is going to become the exponent, so I'm going to have the natural log of the absolute value of y minus 1 over the absolute value of y plus 1. I don't know what I'm going to do about these absolute values, but that's all right. 2x plus c. You know what I'm going to do is I'm going to drop them here. Just say y minus 1 over y plus 1 is equal to a new constant e to the 2x. So what's my logic for dropping them? That I exponentiated, and then that constant can either be positive or negative, depending on if it needs to be positive or negative. I don't think that's really the best argument, but I'm temporarily confused about how to deal with them. So I've just like decided to drop them because I'm pretty sure I don't need them. I don't know. What's our initial condition? 0, 3. Okay, so if x is 0, y is 3, that'll give me 2 over 4, so 1/2 equals c. So c is 1/2. Okay, so then let's keep, where should I write this? I guess we're going up. So we have y minus 1 over y plus 1 equals 1/2 e to the 2x. So we have a goal in mind. This is our goal. And I like kind of feel like we're getting there, but I could understand if you don't feel that way. I'm gonna multiply by 2. Am I gonna multiply by 2? I'm gonna do, should I do the plus 1 minus 1 trick on the left-hand side? I think I should. So I'm gonna do y minus 1 plus 1 minus 1 over y plus 1 plus 1/2 e to the 2x. It's like there's so many ways you can go with this. This is y plus 1 over y plus 1 minus 2 over y plus 1 e to the 2x. I mean, is this going to work? I don't know. Minus 2 over... It's going to be a shame if I don't get this. Okay, so I need to subtract 1, multiply by negative. So I'll get 2 over y plus 1 is... Subtract 1, multiply by a negative gives me 1 minus 1/2 e to the 2x. Okay, I don't know, reciprocals, I guess? Jeez, this is crazy. Y plus 1 over 2 is, I was about to be like, where did I lose like the y minus 1? But I think we dealt with that. So I'm taking reciprocals. So multiply by 2, get y plus 1 equals, multiply by 2. 2 over 1 minus 1/2 e to the 2x. And then I have to subtract 1. So first I'm going to simplify that right-hand side and say it's 2, it's going to be 4, so that's disconcerting, over 2 minus e to the 2x. Okay, and then subtract 1. So 4 over 2 minus e to the 2x minus 1. But I'm going to write 1 as 2 minus e to the 2x over 2 minus e to the 2x. So this whole thing, this is 1. I don't know if this is like an interesting video or not. Definitely the algebraic manipulations are not trivial. So like I could see how, even if you really know what you're doing, you might need help like solving this. So this is 4 minus 2 is 2, minus negative is plus e to the 2x over 2 minus e to the 2x. 2 plus e to the 2x over 2. Whoo! Check that out. Wrong color, maybe. I don't know. I mean, there's no such thing as wrong color, but there we go. There we go. Now, why were we allowed to drop the absolute values? I don't know if I have a great explanation for that. So I don't have a good, I feel like I don't have a good, like a really good justification for it. I mean, as long as this is positive, you don't need them, right? So where does that happen? Well, that's going to happen everywhere between certain things. -1 and 1. I mean, we could number line it. Does anyone care? That's one question. I think we already answered this, by the way, the vertical asymptote thing. But here, if you have y minus 1 has it at 1, and then so y minus 1, so it's positive here and negative here, and then y plus 1, -1, and it's positive here and negative here. So as long as y is greater than, as long as y is not between -1 and 1, we don't need the absolute value. Is there a reason to know that y is not, because they'll both be, if they're both negative, you're good. If they're both positive, you're good because the ratio is positive. If you're between -1 and 1, you have a problem. Is there a way to know you're never between -1 and 1? I mean, you can see that you're not here, so you definitely don't need them. But then you run into the problem here, and like maybe that's related to that. I don't know, but you don't need them. Is not a satisfying answer. The other way to do it, which I'm not going to subject you to, is to take the derivative of this, right, and simplify it. And then also, so that'll be this side, and then also to take this and plug it in here and simplify it and show that you get the same thing. That's the other way. I think the algebra is a little less complicated in that one. That is not guaranteed at all. But it's a more straightforward approach. So maybe you want to try that on your own. I'm going to leave that as an exercise to the viewer because I think that this has already taken a really long time. The answer to this was vertical asymptote. I think we're good. I'm going to end this video here. I will be back in the next one to do some more, and I will see you there.